So in this example here, this one is basically the third different kind of example that you might see on the ICE chart. Most of them were given the initial concentrations of reactants, and then we're asked to find, okay, how far does this go in the right direction before it starts coming back and establishing equilibrium, and then what are the final concentrations of everything. That's the first basic type of question. The second type of question that we just did was where you're given an equilibrium concentration of a product and you're asked to work backwards. This one is kind of the third kind. And again, you can use the chart. The chart is very useful, very helpful, but you have to think through this one just a little bit. So it says 0.25 moles of each gas. So that means we have 0.25 moles of everything. Both sides. Okay? So the initial concentrations are given of everything. Again, a lot of times it's just initial concentrations of the reactants and then these are at 0, right? But in this case, we've got initial concentrations, and of course it's a 1 liter flask, so this is molar. Right? So in your chart, your ICE chart, CO, NO2, CO2, NO. We need to figure out, first of all, if this is balanced. Is it balanced? Yeah, it looks pretty good. So 1 to 1 to 1 to 1. All right. Oh, it's not balanced? 1N, 3 O's, 1C, 1C. How's that not balanced? That's balanced, isn't it? What did you see there? Did you miscount the O's? The oxygens, maybe? Okay. But yeah, that's balanced. Okay? So it's a 1 to 1 to 1 to 1 ratio. Got it? So the initial concentrations are given, and that's 0.25 of each. All right, so the tricky part of this question is, how do you fill out the rest of the chart? Or, I mean, really, the next row, how do they change? Well, there's an equal concentration of everything, okay? What do we know about this reversible reaction? What do we know about what it's going to look like at equilibrium? That's the big question. So look at what you're given there. Can you make any observations about what this is going to be like at equilibrium? Okay, so they're all equal. There might not be any change at all. They might just be happy right there. Okay, that's one option. Anybody agree with that or disagree with that or have any other ideas? Okay, it's balanced. What's the KEQ there? What's the KEQ constant? 1.46 times 10 to 2. So that's 146. What does that tell you about the equilibrium of this system? That the products are favored, right? So the products are going to end up to be higher concentrations than the reactants. That's your key right there. Okay? That's your key. So if these are all equal right now, how's this going to change? At the end, we know from the KEQ right here that we should have higher concentrations of the products, these two. So if there's going to be a change, and right now they're all even, what's the change going to be? Yes, exactly. These two should be higher at equilibrium than these ones. So if they're all even right now, these ones should go down, and these ones have to go up. Okay? So you kind of have to think through this. If you understand what the KEQ tells you, that the products are favored, that means that there's higher concentrations of products at the end. Okay? So, how much is this going to increase by? Yes, we don't know, right? I don't know. This is when it's okay to say I don't know. So this is going to increase by X, this one. Now, this is a 1 to 1 ratio, so what's this one going to increase by? X. Very good. Now, what is this going to decrease by? X. And this one? X. Yeah. See, they're all 1 to 1 to 1 to 1 ratio. So the amount of change is going to be the same. So whatever this one goes up by, this one's going to go down by. So now we can fill in our equilibrium. 0.25 minus x, 0.25 minus x, 0.25 minus x, and so on. Oh yeah, plus x, thank you. And then we can fill in our KEQ expression. Okay, so you guys go ahead and do that. Okay, try the rest of this on your own. And then I'll show you the correct answer in a couple minutes. Alright, so here's how your question should have turned out. KEQ expression, right? Products, the multiplication of the products divided by the multiplication of the reactants. Take the square root of both sides, solve for x, plug x into the equilibrium row, and you should get the concentrations for each. Again, significant figures I'm not too worried about right now. There would be only 2 significant figures in these if we were writing these down significant figures. I'm not too worried about that right now. I just want to make sure that you do your calculations properly. But if you wrote this as 0.038 for these ones and 0.46 for these ones, that would be great as well. All right, so that's how that question turns out. This is sort of the third type of question you might run into where there's concentrations of everything, and then they're allowed to react to equilibrium, and you just kind of got to use your brain a little bit to figure out how this chart might be filled out. But chart's a good tool. So you have some other questions in your assignment. I'll let you go ahead and work through the assignment now. A lot of the questions are very similar to the ones that we've done here.